In this video, let us work on continuing the setup of our enemies. Right now, what we have is this BP enemy class. They are a character class. They don't do anything right now, but we just created it so that we could get, we could see the players like shooting logic, and we could get this, we could detect when we're hitting these enemies. So we have some of the shooting logic ready. Now we are going to set up the enemies to make them feel more lively, like actual enemies rather than just static models there. And finally, let's finish it off by getting the enemies to interact with the bullets. They should die when the bullets hit them. And the enemies to interact with the player. If the enemy, in our game at least, if the enemy runs and hits the player, our player is going to die. So to start, let us get our enemies moving around. Our enemies was of type character, so getting them to move is going to be fairly easy because the character movement component already lets us move, and it also lets us control these parameters. Remember, for our player, these same parameters affect our enemy. So for example, we have this max walk speed that we could use to affect our players walking. We can do the same with our enemies. So it was 600, I just changed it to 300 just for now, so our enemies run a little slower than our players, so we can just see it and they don't run to our players and get stuck. And also, Unreal gives us this really nice function called AI Move To. This takes a pawn. In this case, the pawn would be self. And it takes a destination. And whatever location we put in here, our AI will move towards there. They will avoid obstacles and they will move towards there. But how do they actually know where to move? Like, how would they know what is an obstacle and what is not? We have a way of accomplishing that called a nav mesh. A nav mesh, as the name suggests, is a mesh. It's not like a mesh that's visually there, but it is a mesh in the sense it consists of vertices and edges, and it will tell the AI what is something they can step on and what is something that we can't move on. To make a nav mesh, we have to make a nav mesh for every level that we have. We can open our window and open the place actors window. And under volumes, we have a nav mesh bounds volume. We just drag that in here. And if I was to press the P key on my keyboard, press P, you can see we turn on the nav mesh visualization, and we can see this little green area. Green means that our AI can walk there. So I'm going to go under brush settings and just increase the size of this nav mesh to actually cover the entire level. And you can see that we have this whole area green. If, for example, I added a cube in here, you can see there's a little area around the cube now we cannot go in. The reason it's not perfectly set up to the cube is because our player's mesh or our AI mesh has like a collider on it, and you don't want your AI getting stuck onto objects, so there tends to be a little bit of padding between objects and a little bit of padding between objects that our AIs can't step on, so obstacles, and the rest of the floor, so that they don't really just get stuck in here. We can actually edit these settings in our of our nav mesh. So when we added a nav mesh bounds volume, Unreal also automatically added this recast nav mesh, and this is where all the settings are. So we have this agent radius. You can see if I turn this radius up, it'll give us more padding, and we can turn the radius down to have even less padding. But always, it's good to have some padding. There are a ton of settings here that you guys can mess with, and really the settings are going to depend on the kind of level that you make. Everything is going to depend on the type of obstacles that we have. So once we have our nav mesh set in, I'm not sure why my nav mesh turned off, but okay, not sure why it showed and then it didn't show. Anyway, quirks of Unreal. But now our nav mesh is here. We can see the green areas where our AI can walk, and the white areas are where they cannot. If I was to make a new object, it should rebuild and affect that object as well. So this is how the AI is going to be able to know where they can move in the level and where they cannot. So if we wanted this AI, for example, to move here, they will know to follow this path around these obstacles. And they'll usually pick the shortest path and try to find their way to that location. Okay, so now we have the nav mesh down, which gives our AI, or like helps them know where they can move. And we know we're going to use this AI move to function. How are we going to get the AI, or we need to set up the logic for our AI to move. The way I want to set my AI up in my game is to have two states essentially. One of the states, the main state, is they're going to be chasing the player. So they're just going to find the player and they're going to run towards them. If they touch the player, our player dies. But I don't want them to, if our player was somewhere across the map, I don't want the AI just somewhere else across the map to just keep running towards the player. Instead, they're only going to run towards the player if they see the player. When they don't see the player, they are going to be in a patrol state of some kind. They're just going to pick a random location near them, move to that location. Once they reach that location, they're going to wait there for like a second or two, pick another random location near them, move there, and keep repeating that. They're going to be patrolling. When they see the player, they're going to switch from patrol to running. This is one of the most, or running towards the player. This is one of the most basic forms of AI in games. They just patrol, and when they're near us, they chase us. And so we're going to do that. I think this is a good starting point for getting our AI built. So to do that, I had mentioned when the AI sees the player, they are going to run towards them. So there is a component we can use for that. It is called pawn sensing. And we can just add that in here. And if we go back into the viewport, we can see this pawn sensing has added some stuff here. A pawn can be sensed in two ways: visually, so seeing, or through sounds or noises in this case. So our pawns can hear or this pawn sensing component can hear a noise, or it can see another pawn. We are not going to concern ourselves with the hearing a noise component of this. So our pawns or our enemies are purely going to work just on sight. Without confusing you guys, I just want to mention that this noise component doesn't actually have anything to do with sounds, as in, it doesn't have to do anything with those play sound 2D or play sound location nodes. It's not like those audio noises we can hear. We would add a noise emitting component to a different actor, in this case our player probably, and we would, when we play these sounds, for example, so on walking, we can also tell them to emit a noise. Again, this is an auditory, it's like a separate system, and I don't want us to get confused with that, so we're not going to be using that, but just, for your knowledge, just know that this noise is not the same as those play sounds that we hear. We call it noise because conceptually it is like a it's audio, but it's not really like the audio component of Unreal. It's its own thing and has its own setup required for it. We're going to just work on the C. So let's just start off by looking at what we see here. We see two spheres. We see a yellow sphere and a blue sphere. This is our hearing radius. And this is the radius that our AI's pawn sensing will hear noises from. We don't care about that. In fact, under AI, hear noises, I'm just going to turn that off because we don't need noises. We're concerned with the vision. Here we see this like polygon here, this green one. That is our vision cone. If I look at this setting here, peripheral vision angle, and we reduce it and increase it, we can see it becomes a little cone. And this is kind of like the spotlight that our AI can see in. I'm going to leave it at 90, so anything in front of them, they should be able to sense. So just like an overlap event, our pawn sensing, if we come under events, has on see pawn. So when we see a pawn, as long as our AI is detecting a pawn, it's going to keep running this function. And so on this function, for now, let's just print a string and see this working. So to do that, we have this pawn output here. This is very similar to the on begin overlap other actor, except this is just specifically a pawn. This is the pawn that we see. And so we want to check if this pawn has a tag. And we want to check if it has the tag player. I'm just going to double check that I did actually tag my player as player. So let's go to inputs, or I'm sorry, twin stick, open up player. Let's check their tag. So my player has an actor tag of player, so this will work. And let's branch on it. Now, if this is true, let's print a string. Let's just say I see you as true. All right, let's go see if this works. So nothing, they don't see us. And if I walk in front of them, you can see it says, I see you. And as long as they can see us, it's just gonna keep printing this function because it keeps running every frame when they can see us. So instead of them printing I see you, let's actually get the pawn to move towards our player. We can do that with this move to. And again, the pawn is going to be ourself. The pawn that we're moving is this pawn, this enemy BP. And instead of setting a destination, we can just set the target actor as this pawn, which is the pawn that we see, which is going to be our player pawn. And let's go see if this works. So right now they don't see us, nothing is happening. And they see us, okay, and they're going to start chasing us. Okay, great. So we got the little chasing thing working. They're still in T-pose. We got to like set up some animations for them, but we got this part working. Great. Let's also set up their patrolling now. So right now we have this when they don't see us. So when we just started, for example, they're just kind of standing there. They're just waiting to see us. Is a little unnatural. We want them to patrol when they don't see us. So let's set that up real quick. So to do that, I'm going to make a custom function, custom event. And I'm just going to call it move to random location. So this function, as the name says, they're just going to move to a random location. So there's another function we can use that's very convenient. It's called get random location in navigable radius. So anywhere in the player's radius that they can actually navigate to, we're going to find a valid location there. The origin of this radius is going to be the actor's location. So it's going to start from, the center of our actor and then work on a radius going outwards. That radius can't be 0. Let's just set it to something like 1,000. And we want to use, again, the AI move to function to move there. The destination, instead of using target actor, let's just set a destination that's going to be this random location. And finally, on success, so once they've reached that, let's just delay by 1 second. And when they complete it, let's call the move to random location again. So when we run this move to random location, they're going to get a random location somewhere around their area, move there. Once they've moved there, once that move is successful, we're just delayed for a second to let them just wait there. And then let them move again. We're going to call this function again, so it's just going to keep going in circles. This function will be broken when they see us because this runs every turn, or this runs every frame, so it's going to override this function. But just for us to visualize it real quick, I'm going to turn off this. I'm just going to delete this node so this on-see pawn isn't connected to anything. Let's just see them patrolling first. But before we run it, we have to actually call this move to a random location once, and so let's just do that in begin play. So now when the game starts, we call this move to a random location first, once, and then it runs through, and it's just going to keep looping over and over again. So let's compile it and check if this works. Hit play, and it does not work. If we go real quick, check why. I see. I have not given this AI move to which pawn to move. We want to move ourselves. And that should work now. Great. So you can see they're moving. They found a location. Wait there. Go wait there. And let's also plug up our on-C pawn, see them both working together. What I'm going to do is just move my player somewhere else. So let's move our player back here. Oh, that was not the player. There you go. Let's move our player back here. And let me also just zoom the camera out a bit more so we can see more of the levels. Instead of 600, let's have it at 1200. And you can see, oh, they see us already. So you can see that one's patrolling. They're patrolling. Some of the character, or this one sees us, but the other ones are patrolling. And now they see us, they're going to be chasing us. Great, so this patrolling, and when they see us, they're going to start chasing us. That stuff works just fine. The one kind of issue right now is once they see us, they're just going to keep moving towards us. They never break that line of sight. This is something we don't want. Instead, we want them to, if this function stops, like if they don't see us for a while, you know, we want them to go back to patrolling. We don't want them to just chase us forever. At some point, they got to break. And to do that, I'm going to, on our AI move to, once we start moving, let's just call a retriggerable delay. Set it for 1 second. And when it's completed, let's call the move to random location. And so what a retriggerable delay does, it is like a normal delay node. It delays. So when it runs, we're going to start a countdown. Except when in a normal delay, it doesn't matter how many times we run the function, the delay is always just going to keep counting down. In a retriggerable delay, if this trigger is, or this delay is currently running, so let's just say the delay was running, it was at 0.5, and then this function runs again and it triggers it again, it'll just reset the delay back to 1. So until this function stops running for 1 full second, it's going to keep retriggering that delay, keeping it at 1. And because this function is going to run every frame when the character sees us, it's going to keep triggering this delay until the character doesn't, or the enemy doesn't see us for 1 full second, and then they should go back to their patrolling, which is just move to a random location. Let's see if this works. For now, let's just delete a few of the AI so that we only have the one. Currently, they don't see us. They're patrolling probably. They see us. Let's go break line of sight here. And you can see they've gone back to patrolling. Again, they see us. We can break line of sight. They go back to patrolling. Great. So that is actually all the logic that we need kind of to set up our player. This enemy AI now is like fairly, I wouldn't say competent, but we have some basic enemies set up. You know, they can patrol, they can chase us when they see us, and our player has the ability to break line of sight with them, which is great. That gives our players some control of how they, you know, want to play the game. Not only do they shoot the players, but it gives them an added level of interaction where they can lose sight of the enemy players by hiding behind obstacles and stuff. And so that, you know, makes our game design much stronger by making our AI implementation also pretty strong. So we have all this set up. I think this video can stop here. In the next section, in the next video, I know I mentioned we'll do the shooting, but really let's first set up our enemy animations, and then finally let's do the shooting. Thank you guys for watching.